So here's one of the graphs that we've looked at already. We should have an idea of what the 1 over x graph looks like. It has the two asymptotes. You should be able to quickly think, where are the key points that I could put on there so that I could graph its shape. Now here, it says that it has been translated 3 units to the left and 2 units up. It just asks for the equation, so we don't have to graph this. It just asks for the equation of the image graph. And I'm going to show you how you could do that, once going directly to it, and another way by using the function notation. Because sometimes with more complicated graphs, the function notation works better. But starting off with it directly. If you could go to it directly, what would this equation look like? If I moved it 3 to the left, where would I write that and where would I show that in the equation? It'd be in the inside, so it's going to be where the x is. Our x right now is on the bottom of the fraction, so that's where the inside of that function is. And we need to show 3 to the left, so that's going to be x plus 3. The 2 units up, that's outside of the function. That happens after the function, so that's going to show up as plus 2. Now, sometimes if this is hard, and the 1 over x graph I think is one of the hardest ones to see because it's kind of weird with it happening on the bottom of the fraction. Sometimes the function notation is a nice step to use along the way, but then you have to be really good and really used to how you use function notation and how that works. So what we're going to say is we're going to say our function is 1 over x, and what we're trying to graph is 3 to the left and 2 up. So in function notation, the 3 to the left happens inside the function, and the 2 up happens after. So sometimes students find it's really easy to write the translations inside the function notation because you don't have to worry about the actual one that we're working with. But what happens now, and I'm just going to do a little bit of work here off to the side to review function stuff with you, is you have to know how to work with functions. So if f of x is 1 over x, what's f of 3? You don't have to write this down, but we're just doing some review. 1 over 3. How did you do that? You just replaced the x with a 3. Okay? And it's so simple that sometimes you don't even realize it, how simple it is. Okay? All we did is, here's the x, here's the x. So when I'm doing f of 3, I replace the x with 3. You might say, oh, Mr. JR, that's real. I know that. That's no problem. But when things get more complicated, when we put things other than a number in there, then all of a sudden it seems like it's more difficult. When in reality, it's the same thing. What's f of x squared plus 6? Okay? That sure looks a lot more complicated than f of 3. But the idea is the same. What have I done? I have inside the bracket, I have x squared plus 6. So if my function is 1 over x, then this will be 1 over, and instead of x, I'm going to write x squared plus 6. And again, all that's happened is I've replaced the inside with this. So let's do a couple more examples just to make sure that we understand this. I'm going to create a new function. I'm going to say g of x is equal to x minus 2x plus 5. What is g of k minus 7? So again, what's happened? The x has been replaced with a k minus 7. So all we do is wherever there's an x, Wherever there's an x, we're now going to replace that with a k minus 7. So when I write this, I still have minus 2, I still have plus 5, but instead of those x's, I'm going to have, and I'm going to write it in little brackets here, k minus 7 instead. If you wanted to, you could simplify this. We now have k minus 9 and k minus, ooh, that's an ugly k, sure looks like an x, k minus 2. That's the idea. So now getting back to our question, how do we do this same question in function notation? Well, we call the original function f of x or g of x, some sort of function. And then we know that it's 3 to the left and 2 up. So we can write that as an x plus 3 inside and a plus 2 after. We recognize that there's our x. And we're replacing our x with an x plus 3. So when we go to write our explicit equation, here's our function. Our function is getting the x replaced with an x plus 3. We have a plus 2 afterwards. There would still be a plus 2 afterwards. And that allows us to use the function notation to write the explicit equation that we need. So sometimes you're going to be able to go to it directly, and that's great. But if it's a really complicated function, if it had lots of x's in lots of places, you might want to take the time to say, okay, this is function notation, and then I just need to replace things in certain places. 12, 13, 14, and 15.